What up, YouTube? Welcome back. It's your favorite math teacher, Mr. Stevener, coming at you with another video. Today, we're talking about two things. Technically, three things. Before I jump into that, don't forget, see that button right there? That guy right there? Press that. That way you guys can get more content when you need help. Okay, I'm here for you. I want to make videos for you guys. In fact, the video today is a request from one of my subscribers because I want to help you guys. Okay, so hit that subscribe button, and so we can make more videos for you. When we get to 1,000 subscribers, Tommy told me he's going to sing.
I didn't.
He told me he's going to sing.
Oh, man.
It's going to be fine, dude. Don't worry. He'll sing for you guys. We'll make a video of him singing. All right? So let me jump into it real quick. First off, somebody asked me, they wanted to know what program I'm using to create these videos. So I'm using a couple different things. So the first one I wanted to show you is I'm using this program called Obs Studio. Okay, Obs Studio is a free program that you can download. It is awesome. It is useful because what it allows me to do is, besides create this crazy infinite illusion, it allows me to capture my camera and put it wherever I want. Okay, I can make my picture bigger. I can make it smaller. I can even move it to different parts of the screen, and it's going to do that in real time. I can also turn my display off, which is my background, right? So if I were to take and minimize this now, you guys can't see anything except my picture. I can also have multiple cameras. I actually have another webcam, and that's what this part is right here. I can actually use that to do different angles if I wanted to. It also allows for streaming. You can do streaming on it. You can record videos like I'm doing right now. You can even edit some of those videos in studio mode. So it's really cool. It's called OBS. I also use this stylus pen bag thing from Wacom. It was like $50. That's kind of expensive, it seems like, but I think it was a great investment because it allows me to write on screen. One of the most difficult things to do for me as a teacher is write on screen. This helps me out a lot. So I had requests for those, so I want to talk about those first. Hope you guys enjoyed that. Now jumping back into the video, the topic today is actually adding and subtracting fractions. I had a request for this, and I get it, guys. Adding and subtracting fractions is super tricky. Okay, there's a really helpful video that you guys can watch. If you go right up there to the top corner, there's a little I. If you hit on that information button, I'm going to post a video that goes to LCM and GCF, which is least common multiple and greatest common factor. This actually helps with that as well. All right. Otherwise, let's jump right into it. Tommy, are you ready?
Oh, yeah.
Ow, that hurt.
Are you okay?
Yeah, I'm fine.
Hey, guys, I missed you.
I know you think you missed them. So, Tommy, you might have to do a lot more talking today because I'm actually kind of losing my voice.
Oh, no, that's not good.
I know that's not.
Wait a second. If you lose your voice, doesn't that mean...
Doesn't that mean what?
Never mind.
Okay. I don't get what you're saying, but maybe I'll get it one day.
Yeah, when you're older and have more hair.
What'd you just say?
When you are older and have more hair. See, now you're going deaf, too.
Oh, stop it. Be nice.
Yeah, sorry, be nice. Be nice, guys. Be nice. Nice.
Yeah, nice. All right, so what we're going to do is we're going to take a look first off, Tommy, at adding. There's two different things you're going to see when you add and subtract fractions, okay? First thing we're going to talk about is what happens when you have, this is actually the second thing we're talking about, sorry. You're going to have what happens when the denominators, these guys right here, are not the same, okay? But we're actually going to start off with what happens when they are the same. Are exactly, are the same. So when they are the same, this is super simple, and there's a reason I started here. It is so easy, and here's what you have to keep in mind, guys. These denominators don't change, and I'll show you why in just a second. This is actually going to be 4/3, and we'll talk about what that means in a second, but it's 4/3, it's an improper fraction. There's a reason this never changes, guys. Fractions are what they call part of a whole, okay? Or there's pieces to some whole, okay? So imagine you had a pie, okay? And well, let's say you have two pizzas. Sorry, we'll have two pizzas, okay? You with me?
Yeah, go ahead. I see. good circles, but I see it.
I know they're not very good circles, but I know you see it. So if I take this guy right here and I cut it into thirds, it's not the best thirds in the world, but you can bear with me. If I cut that into thirds, and then I color 3/3, so that's 3 pieces of the third, just like this. We're going to pretend those are all the way colored in, okay? And I color over here 1/3. See that, Tommy?
Yeah, I see it.
Okay, so that right there, if I were to add those together, keep in mind, consider them pizza, right? So this is a whole pizza. The size of the pieces are thirds, right? Do you see that part?
Yeah.
Okay, so because the size of the pieces are thirds, we're now looking at how many pieces do we have. So in this one, we have one piece that is the size of thirds, right? Okay, now we have, on this side, 3 pieces that are the size of thirds, okay? If I add those together, did the size of the pieces change?
No, they're still thirds.
Exactly. That's why that denominator stays the same, because the size of the pieces didn't change. Denominator means that's the size of the pieces I have.
Oh, that's kind of cool. I didn't know that.
I know, a lot of people don't know that about fractions, so that's why I wanted to show you.
You interrupted me.
Oh, I'm sorry, I didn't mean to interrupt you.
I was just going to say I like pizza too.
I'm glad you like pizza too. So I do need to add, though, my numerators, because those are how many pieces I have. So that's why I get my 4/3. Okay, so let's do another one real quick with the same. So if this is broken up into fourths, what do I have?
The first one is 2/4.
Good, 2/4. And it's okay if you keep it like fourths like that, okay? I know technically 2/4 is a half. What about this other one?
1/4.
Yep, 1/4. Size of the pieces stay the same, right? So I'm still looking at fourths, but that becomes 3/4, all right? So guys, I want to start there because that's the really simple aspect of being able to take fractions that have the same denominator, or that same bottom number, same size of the pieces, and adding them together. Subtraction is the same thing. Difference is you might get something crazy, guys, where you'll see something like this, okay? Don't panic. Really, don't panic. It's okay. Your size of the pieces are still the same. It's fifths, okay? But what's crazy about this is going to be 4 take away 6. So imagine you have $4 and then you lost $6.
Wait, but I'd have negative money.
Exactly. You'd have negative money. This would actually be -2. You can have negative fractions. That is going to happen. That might be some curveballs you see.
Oh, okay, go ahead.
All right. So one more thing to add to this. If something happens where they're mixed numbers like this, you might see the same thing. Keep in mind, you would still expect those denominators to be the same, okay? When you see whole numbers, you can add the whole numbers and then add the fractions in this case, okay? So this would be 5, and 1/2 and 1/2 is 2/2, which is really just 1. So this would be 6, okay?
Yeah, I think I get this. Okay.
Okay, so guys, if you stuck with me this long, please keep going because this is where it gets difficult.
Oh, man.
It's not so difficult that it's going to be bad.
Are you sure?
I'm pretty sure because I'm going to teach you some methods that are going to help you, some tips and tricks, okay?
Okay.
So tune in. Trust me. I love that you guys have gone this long. Bear with me. So now, what happens when the denominators are different? Okay? Because I have kids all the time that are going to give me this right here is 2/5. This right here, guys, is not correct. Don't ever do that. What was that? What are you doing?
Don't do that. I was eating it. Eating it.
All right, whatever. So I think you're kind of crazy.
I know.
So 1/3 is that what I had?
I don't know.
Plus 1/2. Okay, I'm kind of thirsty. So that being said,
don't do that. I'm going to drown.
what do you mean you're going to drown?
No, never mind.
Okay. So when you get this, here's the most important thing, okay? Do not start adding until you make the denominators the same. Because remember how easy those denominators were when they were, or how easy adding was when the denominators were the same?
Yeah.
Okay, so now you're going to make them the same. And here's how you're going to do this. There's some rules to it. Okay, the reason I picked 1/3 and 1/2 is because I can draw pictures for these. So I'm going to draw 1/2 or a third. I know that's not the best third you've ever seen. Get over it. And then I'm going to also draw a half. Okay, right now I can't add those together, Tommy, because the size of the pieces aren't the same. But here's the thing. I can make the size of the pieces the same. I can. Imagine they're pizza, right? If you had friends and you need to share them all equally, well, wouldn't you just cut the pizzas up?
Oh, yeah?
Okay, so that's what we're going to do here. So what I'm going to do is I'm going to take this number and this number, the 2 and the 3, and I always bring them over here to the side, and I put them vertically like this. And what I'm actually going to find is the LCM, or the least common multiple. Okay, another thing you might hear is you're looking for a common denominator. Okay, I always D-O-N, denominator. Gosh, I need to be a spelling teacher apparently. I can't spell. So, common denominator. All right, you're looking for that first.
That is a hard word. I can't even say that.
Denominator.
Yeah, what you said.
Okay, you're going to take them and you're going to find the LCM for that. I posted a video, guys. Go to that take a look at it if you need help with that, because I'm not going to do a huge lesson in that for sake of time. Okay, so what I'm going to do is I'm going to find what my least common multiple is in this case. It's 6. Okay, so because it's 6, what I know is that I can turn thirds into sixths, and I can turn twos or halves into sixths. Okay, with thirds, all I have to do is cut each one in half. Watch what happens. I now have 1, 2, 3, 4, 5, 6 pieces.
Oh, that's crazy. Oh, wow.
Yep, and then this I can actually break up into thirds, and I can make sixths. Now all these pieces are the same size, and I have 6 pieces.
That's so cool.
Yeah, to look at it from a mathematical perspective, I need to know, how did I get from 3 pieces to 6 pieces? What I have to do? Well, I had to multiply by 2, right? 3 times 2 is 6. For this one, I had to multiply by 3. 2 times 3 is 6. But here's the catch. This is my tip. Do not forget this. Talking to you, Tommy.
Oh, me?
Yeah, you scared me a little bit. You got like all up my grill. Yes, this part is important. If you change the denominator, you have to change the numerator.
Okay, I get it. You're scaring me.
Okay, sorry. So you have to change the numerator by the same thing. So if I multiply this one by 2, I have to multiply my numerator also by 2. Are you with me? So that means 1 times 2 is 2. What did I multiply this one by?
3.
So what do I need to multiply the numerator by?
3.
Exactly, 3. So this becomes 3/6. Now, my denominators are the same. So all I do is keep the denominator the same, and I add across, which is
5/6.
Exactly, 5/6, and you're done. Okay? What I want to show you is what that looks like with a picture. Okay? So I'm going to go, and I'm going to break up my initial thirds here. So bear with me, Tommy. Bear with me, YouTube. Just trust me on this. You're going to see why this happens. Okay, so my first part of the problem, what I had is I had 1/3. Right? That's this right here. Okay? Shaded in. The other part I had is 1/2. Okay? Watch what happens, all right, when I cut it, like I said. Okay, so this one I'm going to cut in half. Right? So now that I make 6, I cut each one of those in half.
Yeah, I see it.
Okay, this one I'm going to cut into thirds. Okay. Now I change that into 6. Keep in mind, I change the size of the pieces. But watch what happens, Tommy. I change the size of the pieces, and how many of those pieces are shaded?
2.
Exactly. 2/6. I know. Just wait. Just wait. And this side, what are the size of the pieces?
6.
Exactly. How many are shaded?
No way. It's 3.
3/6. Just like I did over here with the math and the multiplication. Okay? The reason I showed you the multiplication way of multiplying is because sometimes you're going to get things like 13ths and 14ths, and you don't want to have to draw that picture because that's insane. But I recommend drawing a picture is always a great idea. But you use LCM, you multiply, you're able to add those together. We're going to do one more, Tommy. Okay? You with me?
Yeah, go ahead.
Because I'm going to throw a curveball at you. And if I get something like this, okay, guys, you're going to see things like this as well. The key is don't panic, okay? Don't panic. Trust me, all right? So because you see this, okay, you can actually do 2 things. 1, turn both of them into improper fractions and then solve it, okay? I've done a video on that. Or you can just change the fractions and then add the whole numbers. I'm going to do the improper fraction way because it's more challenging, so it's a good way to teach you guys the practice of it, okay? So, as a reminder, to turn a mixed number into an improper fraction, Tommy, you're going to do the denominator times the whole number, and then you're going to add the numerator. So 7 times 5 is 35, plus 1 is 36.
You lost me.
Okay, just hold on. Just trust me. 7 times 5 is 35 plus 1 is 36. I put that over 7. Don't panic. Plus, I have 4 times 3 is 12. Plus 3 is 5. Doing the same thing. The process is always this. Okay? Which is 15/4. So now, all I'm doing, don't panic, relax. You're hyperventilating. Relax. Trust me. What did I say the next step was when you're trying to add them and the denominators weren't the same?
Oh, wait, make them the same.
Make them the same. Remember how I brought them over here? That was my clue. And I tried to find the least common multiple. Okay, so I'm going to do that. 8, 12, we'll keep going. It's going to be 16, 20, 24, 28, right? It looks like it's going to be 28, Tommy. That's my least common multiple. Look, 28. So now I'm going to rewrite right here. So I want to turn 7s into 28s, and I want to turn 4 into 28s. That's going to be the same size pieces. 7 times what gives me 28?
4.
Exactly, 4. So there's 4. Almost did that crazy thing with the pen again. So times 4. So that means I'm going to multiply my numerator times 4 as well. Okay, so 36 times 4. 4, 2, 14 is 144. I should have known that. 144. Okay. How did I get from 4 to 7? I multiply, or 4 to 7.
You gave me the answer.
I know I did. Times 7. So that means I need to do 15 times 7, which is 105. Okay, so now I'm back to just being able to solve it. I know this seems like lots of steps, but in all reality, fractions is very similar to adding decimals and things. It's something you're going to see a lot in your life. So I'm going to do my denominators the same, which is 28, and then I'm going to do 144 plus 105 to give me 249. Okay? Technically, I would then divide. We'll do that real quick just to give the group some time to divide. It doesn't go into 2. Remember, I said place value is important. It doesn't go into 24. It's too big. How many times does 28 go into 249?
That's hard.
That is kind of hard. Why don't you try it?
I don't want to. 9 maybe?
Okay, 9 maybe 2 times 7 is 18 is 252. So a little bit too much if I did math right. Did I do math right?
No.
Oh, I didn't? Okay. 72. 2 times 9 is 18 plus 7 is 25. Yeah, I did.
Oh, sorry. 8.
2, 28. 4, 6, 22. That looks about right. So remember, Tommy, if I subtract these and I get a number bigger than 28, then I did it wrong. Okay? So it goes in 8 times. I'm actually going to stop. Here's the shortcut. We're going to rewrite it as a mixed number. It goes in 8 whole times. It has 25 pieces left over. And what were the size of my pieces, Tommy?
28.
28. So that's actually my fraction. So this 8 and 25/8 would be the correct answer.
Oh, man, that's kind of easy now.
It is. So quick rundown. Quick thing. 3 tips when you are doing this, okay? If you get a mixed number, turn it into improper fraction, okay? So you want it in fraction form. You take the denominators, you bring them to the side, you find a least common multiple, okay? Then you take those and you change it by what you multiply by, right? That's what I'm looking at by right here. How did I get from here to here? Since I changed my denominator, I have to change my numerator by the same thing. I did that here, okay? Are you with me, Tommy?
I think so.
And that, my friend, is how you add. You do the same thing for subtraction, fractions that do not have the same denominator. What do you think?
I think you are a masterful teacher.
You're just saying that.
I really am, because you're, yeah.
Okay. I appreciate you guys. You're awesome. Don't forget, hit that subscribe button right there.
Yeah, that one.
Don't eat the subscribe button.
What?
Just... If you guys watched this video all the way through, thank you so much. Don't forget to hit a like on that so that people keep watching these videos, all right? Look for more videos. Thank you guys so much for being here and sticking with us. We love you guys a lot. We're here for you.
Yeah, we are.